hope the sound's working. Alright, so we're going to walk through the first couple of steps together, and this is being recorded for reference. So I've copy and pasted the code on the right-hand side of my screen. We'll walk through, let's say, getting the buttons to appear. These suggested steps is what we'll go through. And as a reminder, a lot of like the Pig Latin, like Google Billboard, like Palindrome, if you're stuck on where to start, do the coding bats, because we will be copy and pasting a lot of the coding bat functions into our Minesweeper program. Specifically, count neighbors, is valid, and a bunch of other things. So assuming you've done steps 1 and 2, we're moving on. So line numbers may be slightly out of date, so look on the right-hand side and follow along here if you're in class or watching this video online. So on line 2, delete the comment that says create 2 integer constants, num rows and num columns, and initialize them with valid 20. Okay, value 20. So that's right here. All right, that line number is the same. Instead of, well, yeah, let's follow the steps directly. So we'll delete this. We're creating some constants. Let's see. Do things need to be private? I don't think so. But I don't think it will hurt your program if you did make them private. They're integers. They're, what is it? There was a specific word for making constants. Was it static? And then final. Yeah, there we go. And then we, all caps, num underscore rows equals 20. That same line, we're going to make again. Why doesn't it like this word? What does it say? It says identifier blank. I think the order matters here. Does the int need to go here? Is that better? Yeah. All right, so public or private static final int. Weird, silly Java. One more, int num calls equals 20. So these line 2 and 3 in my program, this just makes it easier later on to test our program to make a smaller grid or maybe make a larger grid. So think back to the Minesweeper that you played on Google, right? You were able to change between easy, medium, hard at the click of a button, and these constants allow you to do this just the same. Imagine that debugging or playing a 10 by 10 Minesweeper is much harder and it'll take a lot more time than playing like a 5 by 5 game of Minesweeper, and the ideas are all the same. Line 4, we go to line 16 and initialize the 2D array buttons to have 20 rows and columns. Okay, so we're using that constant that we've just made num rows and columns, roughly in line 16, which is about here. Oh, look at that. Your code to initialize buttons go here. And notice that there already is a name, right, a declaration for our 2D array of buttons. See that right there? Yes? So half of it has been done. And then the second half that we need to do is say buttons equals new, let's see, and their object type is ms button, okay? ms button. And then we need to say num rows and num calls, right? That's a little bit longer line of code. Let me zoom out a little bit to show you. So this is the next line that I added. And so if you think back to array of objects, right, that's our first call to new, right? The analogy goes, it's not just one floor in your apartment, it's the whole building, right? It's number of floors and the number of apartments per floor. Previously, it looked more like this, right? Just something like that. But because we're dealing with 2D arrays, you need rows and columns, rows and columns, rows and columns. So up here in my line 5 is the declaration of this 2D array of these ms button objects, and this 2D array is called buttons. Down here, I'm initializing it using the new keyword, filling it to hold this many rows and this many columns of these ms button objects. All right. From there, we use the nested loops to rent out or lease, otherwise fill in each of those apartments in this whole apartment building with ms button objects. So let's go for int r equals 0, r less than something, 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 right? And then r, oops, I switched to I. It's muscle memory, right? Something here, then r++, squiggly braces, inner loop, int c equals 0, c less than something, 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 right? and then C++. Squiggly brace, squiggly brace. And then something goes here. All right. I'll give people a second to catch up with typing. So again, outer loop is rows, inner loop is columns. Keep that idea consistent on anything you work with 2D arrays. It's exactly as what we taught you when working with scales way back when in the first semester when we first introduced loops. Now, what do you think goes into this first set of question marks for r less than what? Row, very good. Okay, num rows, right? Alternatively, your code would have worked, and then down here you could have put 20, right? But then you've defeated the purpose of why we had a constant in the first place, right? Imagine if you put 20 here and then 20 somewhere else, and you wanted to change the number of rows and columns. That's a lot of control finding, copy and pasting, and otherwise replacing you have to do. This is the whole reason why we have variables, right? And constants on top of that, they never change in their values. Okay, there's num rows, here's num calls. Now the interesting stuff, right? We must now initialize this each apartment to have a MS button object. So that code looks like buttons. Okay. We got to tell it where, right? So which apartment to be at. Instead of just having one index, right? Now you have two. So now buttons, rows, and columns, right? This floor, this apartment number equals new MS button. And then for this part, we have to go look at the object definition, the constructor for an MS button. Okay, so I'll give people a moment to type this down, and then I'm going to scroll down to go peek at what does it take to initialize an MS button. All right, I'm going to scroll down to the bottom where they have that class definition. Okay, so then I go down. All right, I have some nice functions. Oh, MS button right here. All right, this is the public class definition. Here are my member variables, and I notice my constructor. Oh, look how convenient. It takes in a row and column, just like the Guido button objects do. So it takes in two numbers, in a location on where to store it. So I'm going to go up, and R, C, and we've initialized an MS button object. So we've completed step 5 here in the suggested steps. Now to leave you with something working, these lines in step 6 is where we're going to go to next. All right, now that we've initialized the 2D array of buttons, we filled it in, we're going to scroll down. Now these line numbers will be slightly off. It's actually lines 70 and 71 now in my program, but it really depends on how much you space this out, because we want to uncomment these two lines, which reads width equals 400 divided by num calls and height equals 400 divided by num calls. You may recognize width and height as variables we've seen built into processing, but now we're overriding it so that we fix the correct number of spacings, right? So we just have a giant grid of buttons. Okay. So then from there, right, I think we should be able to run this code. So last step that we did was uncomment these two lines inside the MS button constructor. Now when we press play, all right, so that is what you should have achieved, right? This is the grid that you play Minesweeper on. And you click, these are your nice Guido objects, right? And then we've completed up to step 6. All right, now to show you, like we'll go through step 7, so it makes it easier, right? And also illustrates the purpose of having these constants. So step 6, it says, okay, I want to go way up here, right? Let's say I wanted a 5 by 5 grid, right? So I changed the very top row, the second and third lines. It was 20 and now it's 5. Now when I press play, I have huge buttons, right? And it scales nicely. See, now it's like very easy mode. And you can debug and play the game of Minesweeper just the same with a 5 by 5 as a 20 by 20. Okay, so double check that that works, great. And then I'll restore it. I can be crazy, and I want 100 buttons by 100, and then it'll make tiny little buttons, 100 of them. Give it a second. Come on. Go, my computer. 1,000 buttons, see? If you zoom in, you can actually, like, we'll start clicking them, alright? See, they work. They're like moles on my face. Alright, so that's step 7, I guess. And then I leave you with the rest of the stuff, right? Line 7 onwards, and a couple of reminders as you're working through the Minesweeper program. Although I didn't demonstrate it in the first couple steps, you should be running your program after you accomplish each one. Always ensure you have a working program to build off of instead of writing lots of lines of code and then realizing it broke earlier down the ways. All right. So we've demonstrated a short, 7 steps to get you started with Minesweeper. This Minesweeper assignment for this semester is due next Friday. Okay, next Friday, 2-week assignment because it is a long one, but it will be one of the most satisfying or most accomplished things you'll be proud of after you finish this class. So be sure you save your work from today if you followed along. Save it as Minesweeper, have it in a safe spot, and build off of this. That concludes today's video.